is logistic regression model? Logistic regression is a classification algorithm used to assign observations to a discrete set of classes. It is a predictive analysis algorithm and based on the concept of probability. The hypothesis of logistic regression limits the cost function between 0 and 1. This cost function can be defined as the sigmoid function or also known as the logistic function. What is a sigmoid function? In order to map predicted values to probabilities, we use the sigmoid function. The function maps any real value into another value between 0 and 1. The formula of sigmoid function is given as y equal to 1 over 1 plus e power minus x. So this is the boundary. Less than 0, the value of sigmoid function becomes 0. More than 0, the value of sigmoid function becomes 1. What is logistic regression? This classifier model takes the input data set and gives a set of predicted outputs or classes based on probability. The probability score varies between 0 and 1. In this example, a decision boundary it separates two classes as survived and then lost. The red dots are representing the lost. The blue circles are representing the survived. So here number of positive nodes are computed with this formula. So this curve predicts patient status after 5 years. Now we will see classification with logistic regression. In this example, there are two features known as nodes and age. This is node and this is age. There are two labels known as survived and lost. So there are two kinds of nodes. One is survived. Survived is represented by blue circle. Then the lost is represented by the red circle. So there is a decision boundary between survived and lost. The survived data points are represented as blue circles. The lost data points are represented as red circles. There is a decision boundary which separates these two classes. When a new data point is given as input to the model, then it predicts as either survived or lost. So multi-class decision boundary. In this example, the features are nodes and age. Three classes are defined as survived, lost and complications. So this is survived, this is lost and this is complication. The corresponding data points are represented as blue, red and violet circles. There are three boundaries separating these data points. These boundaries are called as multi-class boundaries. Let us see what is classification error matrix. Evaluating the ML algorithms is an essential part of any project. Many metrics are available to evaluate the performance of ML algorithms. Some of the metrics are accuracy, precision, receiver operating characteristic and area under curve. classification error measurements, a confusion matrix. A confusion matrix is an n by n matrix where n is the number of classes being predicted. Confusion matrix describes the complete performance of the model. Many metrics can be derived from confusion matrix. There are four important metrics. One is true positive, are the cases in which the prediction is yes and the actual output also yes. Both are yes. True negatives are the cases in which prediction is no and the actual output also no. False positives are the cases in which the prediction is yes and the actual output is no. False negative is the case in which the prediction is no and the actual output also is yes. So accuracy is the proportion of the total number of predictions that were correct. What is precision? Precision is the proportion of positive cases that were correctly identified. What is sensitivity or recall? Sensitivity or recall is the proportion of actual positive cases which are correctly identified. Specificity is the proportion of actual negative cases which are correctly identified. Receiver operating characteristics, ROC. And receiver operating characteristic curve is a graph showing the performance of a classification model at all classification thresholds. In this case, we have four thresholds. One is perfect model, another one is better model, and random case, and then worse. Four thresholds are there. This curve plots two parameters. One is true positive rate and another one is false positive rate. That is 1 minus specificity. This is sensitivity. The thresholds can be depicted as perfect model, better model, random case and worse model. The model is perfect when ROC ranks are positive or all positives above all negatives. The model is worse when ROC ranks all negatives above all positives. The model is random case when ROC ranks all positives and all negatives equally. The model is better when ROC lies between perfect and random case. What is area under curve? AUC. Yeah, AUC is the area under the ROC curve. When AUC is 0.9 and above, the model is perfect. When AUC is in between 0.5 and 0.9, then model is better. When AUC is 0.5, the model can be classified as random guess. When AUC is less than 0.5, the model is worse.